Everyone, this session is going to cover the use of the CPV tool. We will go over the setup of the tool and applications of the tool as well. Everyone who's on the meeting, please let me know if you have any questions. But let me introduce what we're looking at first. So this is an example of an inspection that's completely done through CPV tools, picking up data, and then a math tool doing calculations with that. Now, the CPV tool doesn't have to be used with the math tool. It's a tool that can work on its own. So it can be used to give data, and it can be used to pass and fail inspections on its own as well. In addition, it's very often used as a substitute to the locate tool to move other tools based on where it found the object. However, unlike the locate tool, which moves all the other tools in both directions, X and Y, each CPV tool, because it finds edges, can only move in one direction, either in the Y direction because it's looking for a vertical edge, or the X direction because it's looking for a horizontal edge. All right, so the example that we have here is basically doing an inspection on something called a PIBA. Don't remember what that means, but it's basically something that kind of covers the top of a bottle to make sure that nothing leaks. It's kind of like a stopper. So what you guys are actually looking at here is, can you guys see my mouse or no?
Yes.
Okay. What you guys are seeing here is basically the top of a bottle, and there's supposed to be something that is right there that's covering it. Now, from our view, we can't see this thing. That means that it's good that it's exactly covering it. If it is skewed or not really pushed down all the way, we will start seeing it. So this is what this inspection is doing, just so you guys know what the pass and fail criteria are. All right, so this big tool here is supposed to find the edge of that PIBA device. And through these three tools, we're going to actually cover everything that the CPV tool can be used for. It's an excellent example. So let's open this up. And the first tab in the CPV tool is the Edges tab. Now, I prefer to start setting up the CPV tool not with this tab, but actually with the Setup tab. And you guys are going to know why right now. The Setup tab includes all the things that you kind of want to think about when you're trying to use a CPV tool. CPV tool is an edge detection tool. Its job is to find edges. So these edges can be a light to dark transition or a dark to light transition based on the direction that you're going in. So for example, if we're looking at the edge that's here, we can actually go in both directions if you think about it. However, if we go top to bottom, we're picking up light to dark edges because that's the transition that we have here from the backlight to the silhouette of the top of the bottle. If we go bottom to top, if we choose the other direction, it's not going to find any of these edges because the polarity light to dark is not found in this direction. If you go in this direction, it will only work if it finds dark to light transitions. Now, picking the direction is actually a really important thing because it really determines what is the path of least resistance, I like to call it that way, path of least resistance in order for us to find the edge that we're looking for. For example, if this bottle over here had a lot of other textures, it had text, it had breaks in it that happen every now and then, we would not want to go bottom to top because as we go from bottom to top, if there's anything on this bottle that can create edges, the tool will find these edges first. So usually we'd like to go from outside in or inside out based on where it will enable us to find the correct edge that we want for the inspection. For the inspection that we have here, we're basically looking for the edge of the PIBA itself. Now, another reason that we took top to bottom is if this thing is sort of, let's imagine it being pushed up or skewed a little bit. We want it to find that outer silhouette, not an inner silhouette if one exists. So going top to bottom, starting from the backlight and seeing where the first edges will happen is really what we want to do for this inspection. So we're going to pick top to bottom, and then based on that, we will pick the polarity that we want to use for whatever we're trying to do. The sorting drop-down is really simple. By position is always what we use. By position means that if it happens to find whatever edges, it's going to pick the first one that it finds in its way. So it's really going to work with the direction drop-down box that we have here. If we try to sort by strength, it's going to pick the most accentuated edge from within the direction that it's going in. So if it finds another edge, but further down from the top, it will report that edge first. So really, when we're trying to look at this tool from a practical standpoint, we usually like to use by position more so than by strength. All right, let's take a look at detectors. Detectors is basically how many edge finders do you want to employ. Now, if you guys take a look at the CPV tool that we have here, it's got a number of little green lines. These basically represent each single edge detector in the tool. So you'll find probably 16 little lines here if you want to take the time to count them. And each one of these lines is finding the edge in its way. This is very important to use if we're trying to inspect something that might skew, if we're trying to create a line. Anytime we're trying to create a whole line to base an inspection off of, we have to have multiple detectors. And the more we have, the less errors we will have. Now, if we're using it for other applications like just trying to be a location reference, a line might not be necessary, which is what we have in the other tools that are being used as location references, where this one here is just used to find this edge. So we're just using one, whatever position it finds, it will average all of them and just use this. And this one here is being used as a vertical reference, so we're also using one detector there. Back to our first tool. Detector width is the width in pixels for each one of these edge detectors. So these lines that I'm talking about are actually representing the space between each one of these two blue lines that you guys are seeing. Between each two of these blue lines is the width of 10 pixels that we're seeing here. Now, detector width affects how many pixels it will average when it's trying to find each one of these edges. So the bigger they are, the less sensitive it will be to edges that are really, really thin. And the thinner the detector width will be, the more it might find really tiny little transitions, really tiny dips in this line, if you will. Edges to ignore is, for each one of these detectors, will it ignore any edges? So if it finds edge number 1, it ignores it and tries to find edge number 2. This is used sometimes if you know that the tool will always find an edge before it finds the edge that you want. So in our example here, we're not ignoring any edges. The first edge from top to bottom that is light to dark, we will find if I make edges to ignore equal to 1, it'll skip that edge, and it won't find anything else because there's nothing else here. So typically, this is also one of these settings that is usually made to be 0, similar to how sorting is almost always set to be by position. Any questions on the Setup tab? Anyone? Okay, moving forward. Let's go to the Edges tab, which really is where we set the tool to find the edges that we want. Now that we've set up all the major things, the direction, the polarity, and how many edge detectors we will be using, now we are going to be selective as to which edges we will find. If you guys take a look at the graph that we have in this area here, the edge strength plot, this graph basically is going to have a red line that draws the strength of each edge. By strength, we mean how quick and how big is the transition from light to dark or dark to light that we see in each one of these detectors. By default, the tool is going to start with detector number 1. Now, if I click here, detector number 1 is that first one over here. And this is the edge strength plot for this particular detector. This means that it's going and going top to bottom, and then all of a sudden it found this very strong transition from light to dark. You guys are going to see the transition from light to dark being a dip, not a rise, because it's going from a high grayscale value to a low grayscale value. So it's going here. And then it's going to go back up again to neutral as it goes from dark to light. So what you guys see here is a very strong edge, because what we see here is a really, really strong edge. Very sharp transition from very bright to very dark. So this plot is going to be dipped really low, and it shows that we have a very good edge. The bigger this peak, the more strong your edge is. The edge threshold is that green line that's going across. Now, if that green line is anywhere underneath this curve, if we're doing dark to light, light to dark, it's going to find that edge. And it's going to find where the peak is, and that's where the blue line hits here. So the tool is using this to basically know which edges you're going to use. If there are multiple edges, it will pick the edges that are above the threshold, where the peaks are above it. So if I go with this edge threshold to be high, and you'll see this green line going down all the way down. Now, even if I go all the way out there, this edge is so strong it's never going to be not picked up by the tool. Okay. Now I'll show you an extra thing. If I use instead of polarity light to dark, if I go for all edges, which means that it's going to find whatever the first edge that it finds and report that, you'll find that the threshold line is now on both sides of the curve, so that if the curve is going the other direction, we would pick it up with that top green line. However, with what we have here, we're going top to bottom. We can only find one edge within the tool. Let me bring this back to light to dark. Okay. Now, the filter size and filter gap are used to accentuate edges, where if it finds an existing edge, it will increase the peak of the edge by a particular factor depending on how big the filter size is. The other thing that the filter size does is it also would help flatten edges that are not really that strong. We're not going to see this in this particular CPV tool, but you'll notice that if I bring the filter size down, it's going to kind of make this edge thinner. As you guys can see, it's not as wide, and also the peak is not as high. So in this case, if I actually bring the edge threshold a little too high, it's going to start missing that edge because the threshold is underneath the curve. If it's above the curve, it's within. If it's between the curve and the origin, then it will work fine. The reason that filter size can be all the way down to 1, you'll think, hey, it's accentuating the edges, it helps us. Sometimes bringing it down to 1 helps find edges that are not that pronounced. So if you see edges that are not very pronounced, that are kind of faint, bringing the filter size down might help create peaks that this filter might eliminate. Let's bring this back to where it was. Filter gap, you'll notice, kind of makes this area wider. So it also, in a way, kind of averages more pixels out as well within the same area that the detector is working. So these two settings, filter size and filter gap, will change the way this curve looks, and you should use them if need be, if you can't find good edges, if the edges are not very, if the contrast is kind of low, and if you're not finding the right edges, use them in conjunction with looking at the edge strength plot for the detector that you would like, and see that the edges you like are showing up, and using that curve with the edge threshold slider will help you get there. Any questions so far? Okay. Sorry. Let's go to the Runtime tab. The Runtime tab is where we control the results of the tool. The tool has 3 different things that it can return to us. It can return skew, it can return position, it can return straightness. Now, if we use any one of these checkboxes, the tool will basically perform an inspection. It will take a look at the results coming back from the edge detectors, and if it found the skew of the line that it found more, 2 degrees farther away from what it was trained on, it would fail. This is what skew tolerance means, is it will take a look at this line, and if the difference in angle between this line and the line that the tool was trained on is more than the tolerance, it would fail if we turn skew tolerance on. Same thing for position. If the position of the edge, the one that's in the center, like the one that's averaging out all those detectors, if the position that the tool found is different from what the tool was trained on by this amount, positive or negative, that goes for all of them, for position and skew, the tool would fail. Straightness kind of takes a look at the points on the line that the tool found and how straight is this line. Basically, if most of these points lie exactly on the line that the tool ended up making up from all of these points, the straightness value will be low, will be closer to 0, meaning that the line is really straight. The more these edges don't follow a straight line, the more that the value of straightness will be high, where if you have a particular tolerance here and it exceeds it, that means that the line is not straight, and the tool would fail if we have the straightness checkbox on. On the right-hand side, we have use as reference, which we can use for the CPV tool. It can be used as a reference for position, for angle, or both. So what I mentioned earlier is the tool can be used instead of a locate tool. That means we're using it as a positional reference, where based on where the tool found the position, the other tools will follow it in that direction. Show results is basically which result from these 3 are we choosing to show in the tool. So what you guys are seeing here, that 0.7 value, is the straightness result from the tool. If I change this to position, that's basically the position value that, of this particular image, and that's the skew value for this particular image. And these results are based on the difference between the trained edge and the current edge. So, for example, if I move this show results to straightness, that means that the value of straightness on this line is 0.7, which means if my straightness tolerance is less than 0.7, the tool will fail, and it does. So that kind of relates what you're seeing on the screen to what the tool can do. All right, so let's take a look at the other tools that are being used as a reference. So we have the CPV ref tool, this one over here, and we have another one called CPV bottle. All right, so for this inspection, what we're really going to be doing, the method for this inspection is we're trying to see the difference in location between the PIBA, this edge that this tool finds, and seeing if it's raised above the edge of the bottle. And what we're doing is also getting the difference in position between this edge over here and the edge on the bottle itself. So if the difference between these is bigger than a particular value, the tool would end up failing. The inspection should fail. Now, this inspection is going to be kind of sensitive, so it's really important for us to find where the bottle is. So we're also using this CPV ref tool. This one here is placed right above the edge of the backlights, which is never going to move, and it's going to basically track the bottle as it moves left and right. And based on this edge, this tool is going to find this part of the bottle, the edge that's found here at the seam, and then this tool is going to run in the end to find the difference between this, and additionally also assess the straightness and the skew of the line of the PIBA. So let's take a look at this tool here. If we go to the Setup tab, it's going left to right. It's going all edges, just whichever edge it finds, because this is the only one that it would find, but it would probably bring us the same result if we use light to dark. And if we go to the Edges tab, you'll notice here, all right, here's a line. It's also a dip from light to dark, and the edge threshold is comfortably between the peak of the plot and 0. Let's go to the CPV bottle tool. Now this one, the edges are not as pronounced as the other two. It's not a transition from a backlight to a dark silhouette. So this one doesn't have as powerful edges. As you can see here, the peak is kind of odd. It's not as sharp as these are because the contrast that we're seeing here is not that much. Now we're using the filter size and the filter gap to kind of accentuate the existing edge a little more so that we can find it using a lower threshold. So if I bring the filter gap down, you'll find that this all went down a little bit and it's kind of looking more like a wave there. And if I bring the filter size also down, the peak is just so low. We can hardly find anything here because the transition is not very sharp. If you guys look at this area, let me increase the size of the image a little bit. It's not very sharp. Like this area itself is not very sharp, and it's just the way things are because the bottle it has depth to it, and it's very hard to be in focus on both the edge at the center of the top of the bottle and the one that's closer to the camera. So it's not as sharp, but we can see an edge. And if we play around with the filter size to kind of see if an edge can be created, we're starting to see things here kind of curve and show us something that is different from 0. And if we increase the gap, that gets a little bit higher, making it a little more comfortable. Now the edge threshold is 18, which is not bad. I say if the edge threshold needs to be lower than 10, then you need to work on the image to get better contrast. But anything that's above 18, above 15 or so that you can see on the screen is showing you a pronounced edge would work okay. However, you can see here that if we increase the edge threshold a little above 18, then it won't find any edges. So that's the good thing about being able to see the edge strength plot, is that you can know where the edge threshold needs to be. And as long as it's somewhere that's comfortably between the peak of the edge and the 0 point, you're good to go. Okay, so what we have here is free CPV tool. This one is going to be used as a reference. This one's going to be sort of another reference for this tool to find where the edge is supposed to be. Now, let's talk about how all of this is supposed to work. To make the tools follow each other based on location, it's the same kind of concept as having a locate tool, where the tool that should be used as a reference should be the first in the execution order. This one should run after it because this tool bases its calculation based on this one. So let's take a look. Starts with CPV ref, this one on the left, CPV bottle, which finds the edge on the bottle itself. We have the CPV tool that is looking at our target, and then we have a mass tool that's taking the results of everything. So if I want the CPV here, the one up top to be flush on the surface of the PIBA, this one to be somewhere in the middle of the bottle, and they have to run based on where this one is, I move all the tools to where they need to be, and then I train the CPV tools that need to be the reference. So I got my references set up. Now this tool that I have here, it's actually just reporting its position and its skew and its straightness to the math tool that we have on the right side of the screen here. That's really used as a math tool and also as a display for everything that's going on in this inspection with all three CPV tools. Now if I hit test all, I'm seeing the position of the PIBA, and what we're actually seeing here is the distance between the edge that this tool found and the edge that the CPV bottle tool found. Based on these two, we get a value that we're seeing here, and the math tool is basically just seeing whether this value is between the lowest and the highest value that are acceptable for the position of the PIBA. It's also assessing the angle that's coming out of this CPV tool, and it's just taking a look at all of these different results and passing the inspection if everything passes. You guys want to take a look at the math tool?
Yes, please.
Yes. Okay. Let's take a look at the math tool. No people ask about it, so usually the math tool algorithm is something that is going to be done during the evaluation time, and without a lot of work from the field, unless the images in the field happen to be radically different from what happens in the evaluation, which, if it happens, make sure that you get in touch with the evaluation engineer to find the new solution. So let's take a look at what we have here. We have CPV bottle.foundY, which is the Y position of this tool, minus CPV.foundY, which is the Y position of the tool that's focusing on the PIBA. The origin of Y actually starts from the top of the screen, so the more towards the bottom it is, the higher the value. So this is going to give us what is supposed to be a positive value. We're multiplying this by CPV.found line error. Now, found line error is sort of like the straightness value. So what this is going to do is see the value of this. If the line is not very straight, and we set the value at 1.5, meaning that if the line is straight up to a value of 1.5, this equation is going to have a positive value. It's going to be 1. So we're going to take the result of the first part of the equation. If the line is not straight enough, it's many different points are not on the line that the CPV tool found, this part of the equation is going to be 0 multiplied by the result of the first side of the equation. So the result here, instead of being the actual difference, it's just going to say 0. So it will quickly fail the inspection if the edges found by the PIBA CPV tool are not good enough. If it doesn't find a straight line, just basically fails the inspection right away. It reports a position of 0, which is going to fail. Let's take a look at the second equation. It's basically saying that math.result1, what we were talking about moments ago, is greater than math.input1. And it also says math.result1 is less than math.input2. Now, what is input1 and input2? Well, it's right here in the set user inputs. The math tool can take inputs from the user. And here we usually use this to set tolerances, to put in limits. When I said earlier that it needs to be between two acceptable positions, this is the lower limit, math.input1. This is the upper limit, math.input2. What equation 2 is doing is just saying, is the value of the first equation between these two values? If it is, then we potentially have a good PIBA. And obviously, if the result of the first equation is 0, it's nowhere in between those two values, so it would also fail. The third equation is just saying, hey, the CPV.found angle, which is another property that we can get as a result of the CPV tool, is less than math.input3. And it's taking the absolute value because the angle can be +2, it can be -2. All we're interested in is that it's between 0 and 2 in the absolute manner. So if it's -2 and -2 is supposed to be bad, it also fails if it's less than the value of math.input3. Math.input3 is the tolerance of the angle for the PIBA that we are using here. And the last equation is just saying if the result from equation number 2 is good, it will only pass if the result of equation 2 is good and the result of equation 3 is good, meaning that it passed both the position and the angle inspection. And don't forget that we're also taking into account the straightness of the line, because the position inspection is taken into consideration the found line error property of the tool, which will be lower than 1.5 if it's a straight line, higher than 1.5 if it's not a straight line. Everybody feeling good?
Yep.
All right. So let's take a look at some images that we have here. I'll run through the image cycle that was taken from the field. Each image will take about a second. It's just loading all the images, and now we're seeing if the PIBA is not flush, if there's a bit of an angle, you're seeing that these CPV tools are reporting. They're not failing by themselves, but you can look at the results from the math tool. And that first equation being 0 just means that we're not finding straight lines. Now, once you're seeing a value here, that means we are finding straight lines. And we can see a value that's between those two upper and lower limits that we noted. Now, the upper and lower limits is usually done through trial and error in the field, where the field engineer with the customer run a bunch of good bottles. Knowing that they're good, they will take those values and kind of plug them into the tool and easily find what the result is supposed to be. Good. All right, so we can scroll through some of these images. And knowing what we have here as the result that we're seeing is the straightness result, you'll notice that anytime this value here is above 1.5, you're going to see that this equation is going to be reset down to 0 because the line is not even straight enough to base the inspection on. Yep, most of these are just going to be like that. And if there's a chance for it to be good, that straightness value must be less than 1.5. And you're seeing here that if there's any skew, most of the time, because of the texture that's on the PIBA, a decent number of these detectors are not going to be on the line that the tool is interpolating. Here is a line that's fairly straight. We're getting a value here of 1, so it's less than 1.5. We can move forward. And the angle is less than 3. It's actually very close to 0. Now, that angle is going to be a little different every now and then, but it's as long as it's below 3 degrees, the inspection would pass. Excuse me. All right. Now, the reality is, as an inspection like this, we don't really have to use a math tool. The math tool is very good for display of the inspection results, which is very good from a customer experience standpoint. It's usually good to kind of have something that shows you what's actually going on. Now, the CPV tool already has built into it, as we've talked about it earlier, these runtime controls that can enable it to pass or fail based on what it was trained on. So if we train this tool on what is considered to be a good PIBA, and we say, I want a particular skew tolerance, I want a particular positional tolerance, I want a particular straightness, then it will base the inspection off of that, and we wouldn't necessarily need the math tool. The math tool does help display things that help us become a little more precise. But for simple inspections, we can just use the CPV tool. And we're going to use it here and see if we can mimic what's going on using that. Now keep in mind that what the CPV bottle tool is doing is finding the edge that's also being used. We can also set it up in this situation. We can set it up to be used as a positional reference so that this tool, our main CPV tool, will follow it up and down based on where the edge of the bottle is found. Now, if I use this as a reference and I train it, then this tool will be at exactly the same position from this one. And now, if I train this tool based on this being a good PIBA, this becomes my positional perfect point. This line, the angle of this line, is my perfect angle. And if I use a skew tolerance of, let's say, 3 degrees, let's say I have a positional tolerance of 15. And straightness, however, it's not based off of this. It's not based off of tolerance. Straightness is just an absolute value of how straight the line is. So if I'm going to mimic the math tool, I'm going to change this to 1.5. And we can run. We're seeing that a lot of times what you're going to see from this tool is going to match what we're seeing from the math tool. Now, this was running really fast, I know. So let's go through the reject images. Reject number 1 we have here. We're seeing that the value of the straightness is a little too high. So it's going to fail based off of this, and we're seeing here that we have a 0. Let's go to the next reject. It all checks out. Now, if we choose to display some other value, let's say we're going to display, instead of straightness, we're going to display position. The value that you're seeing here is the difference between the current line's position and the trained position. Now, that does not affect the result of the tool. It just changes which number you're displaying here. So it's really important to kind of choose which result to display so that you're seeing the thing that's relevant to your inspection more than other things. Because right now, this is all within the positional tolerance. So if you look at this, I'm like, why is the tool failing? It's only 14 pixels away. I have the positional tolerance set to 15. Well, because it's failing because of something else. So make sure that the correct result that needs to be displayed is the one that you choose to be displayed. And here, straightness is really the thing that's causing most of the failures. And the straightness thing is kind of not used very often. A lot of times we just use the position and the skew without straightness. But for the inspection that we're having here, the reason straightness is really important is because there's particular skews from the PIBA, since we're only looking from one direction, that will not be visible to us as skew. We will just see a curved line like this one. We're not seeing a big difference in skew or position. But because this line is curved, that means the PIBA is skewed either directly away from the camera or directly towards the camera, which makes the line not appear straight when the CPV tool finds it. You're seeing that it causes a curve here, and many of these points are not exactly on the line. So the only way that we can fail this is through straightness. It's a nice little secret for people who are taking this course. Anyway, so this is a good example of different uses of the CPV tool in the same inspection. We've got a horizontal reference, we have a vertical reference, and we have a tool that's doing the inspection based on both these references. And we're covering how the tool can be used to do positional inspections, skew inspections, and also inspect for the straightness of a particular line. Now let's take a look at another example. Any questions on the previous example? Anyone? Say yes if you like it.
Yes.
Thank you. Okay, let's take a look at a cart and contents kind of inspection. We're not going to spend too much time on this. This is basically where the CVP tool gets used a lot is as just a reference in one direction or another so that the other tools wouldn't make mistakes. So this here is a carton contents inspection. We have two blob tools that are just finding a particular object in a carton. The one on the right is finding the presence of the bottle. The one on the left is finding the presence of a syringe inside a wrapping. So if this tool moves too far to the right, it will pick up something that it's not supposed to pick up. It might pass even though this is not the right thing that it's looking at. Same thing, it might pass if this is not the right thing it's looking at. All of this blob tool would pass, but we want it to be here. So we have the correct vertical position, and we're going to use this tool on the right-hand side to find the edge of the carton here. So this tool would be in the correct position so that it wouldn't pass the wrong things or fail if the bottle is there as well. Same thing for this tool. This blob tool will pass if the syringe is there, and it's using this CPV tool as its reference so that it moves left and right based on the position of the carton. Now, this is an inspection that can cause false accepts or false rejects, and this is why we need to be very careful with the positioning of these two tools. Without a CPV tool, this inspection wouldn't be safe. It would be very risky. You wouldn't know exactly where to put the tools. Now, with these tools being there, things will move appropriately with the carton from each end and pass and fail appropriately. So let me revert this so that things go back to the saved locations, if you guys wouldn't mind. And I'll run the inspection for a little bit so we can see some of the rejects that do show up. Excuse me. All right. Let's take a look at a few of the rejects. We have this reject here where the blob tool is appropriately finding the bottle. This blob tool here is finding things, but they're not enough to substitute for a good syringe. As we take a look at a lot of these, you'll find that the position of the tool moves based on where the CPV tools find their targets, making the CPV tools really crucial to the success of an inspection like this. This is only one application of the CPV tools and where they can be used as a location reference. It can be used a lot to find the correct edge of a carton so that a data matrix tool, for example, can be in its right location. Do you guys have any questions?
One question, Tara.
Yes.
So, and I don't know if you'd ever need this, but is it a possibility of being able to use the tool in both instances on the runtime tab?
Yes.
Meaning using it for position as well as inspecting?
Yes.
Okay.
Basically, you can go to the tool itself, and they're two separate things. Use as a reference is its own drop-down box. And if you want to fail and make it, base the inspection on its own results, it can do that too with those checkboxes. So I've never used it for both before, but it's entirely possible.
Okay.
Yeah. Any other questions? Oh, I forgot one thing. Look at that anchor box that we have at the bottom here. This is to basically anchor the tool on the x-axis or the y-axis or the angle, so it wouldn't move if you have this checkbox on. So if I have it anchored at the x-axis, it might move up or down, but it will not move left to right, even if another tool is telling it to do so. So this is going to be useful in situations where you have a locate tool that runs before it, or perhaps another CPV tool that runs before it, but you really get the correct result from it if it doesn't move in one or both of these directions. So that's also another important thing to look out for. The tool info tab has the normal. We have the name of the tool, and we have 4 different outputs, one for edge, position, skew, and straightness. So edge here is basically going to fail if it doesn't find any edges. That's important because, let's say, in an inspection like the one that you have on the screen here, they're not really the tools that perform any of the inspections, but I would say that if these 2 tools don't find the edges, we would be too skeptical of the result of the inspection, so we should just fail if they don't find edges, even if these tools find what they're supposed to find, because maybe they're finding the wrong thing. So because the position of these tools is so crucial to whether or not the results are correct, we have to use the edge result from these 2 CPV tools to verify that the overall result of the inspection is accurate. So even if they're not doing the actual inspection, having the edge result line is important to be on, so that if it doesn't find an edge, we just fail the inspection anyway. All right, let me give you guys one more thing, an extra for this course related to edge detection in general. A lot of times it's really best to use the blob tool not to find its most direct object, but to use it to find edges, where the object that we're looking at will be more accentuated if we use the edges that it presents. This is the prime example of this, where we're looking at this syringe. Doesn't really have a shape. Doesn't really have anything that identifies it other than the fact that it would have, there's a lot going on here in terms of changes from dark to light to dark, lines within the wrapping itself that causes it to create more edges. If we use in the blob tool a filter called edges all, what it's going to do is find all of these different transitions, and any transition is going to be turned into a slightly brighter pixel. And the stronger the edge, the brighter the pixel will be. So you're going to see here a representation of the edges that it finds, and it finds a lot more of that when the syringe is there. However, if the syringe is not there, barely anything. So if we use this with the blob tool and use the total area as our criteria for passing and failing the inspection, the blob tool will have a very good criteria that will not pass if something else is there, even if it finds a good portion of the bottle, because the bottle will not have as many features on it. It'll maybe find that outline of the bottle, but it won't find much else, not nearly as much as when a syringe is actually there. Notice here that the value here is like, it's jumping between 4, 5, 6,000, but when the syringe is not there, it's much, much less. Look at that, 141, 124. Worst case scenario, bottle there, it's finding almost 1,000 pixels, but it's still a far cry from when it actually finds a syringe, when it finds thousands and thousands of edge-related pixels. Okay. One last cry for questions. Thank you guys very much. This is now going to be uploaded. We're going to stop recording. Thank you guys very much for attending or for checking out this little tutorial on the CPV tool. Good luck.